Okay, so we're recording. All right, so this is quiz 4, and in order to be able to solve this system by elimination, what are you going to try to do? You're going to try to get rid of the x's. So if I multiply this by -1, you get this. When I add the equations together, I get 0 plus 0 equals -10. All right, is that possible? No. So this is inconsistent, and it is the null set as far as solutions are concerned. All right, now, the second one says, solve by determinants using Kramer's rule. I did not see everybody using Kramer's rule. All right, in order to do Kramer's rule, we're going to first of all have a denominator that is made of the determinant for the coefficients of the variables. So I'll have 3 times -7, which is -21 minus 20. -21 minus 20 is -31. Both denominators of the coordinate point is going to have -31. Now what goes on the top, we substitute 2 and 17 and keep the 4 and -7. And then on this one, we're going to keep the 3 and 5 and put the 2 and 17 where the y is. Now the determinant for this is -14 minus 17 times 4. And I don't have my calculator with me, so how much is that? -14 minus 17 times 4 is -82. And so when I divide that by -31, and what's that, 31, not 41?
It was -31.
Was it 31? Let's see, 21. No, 21 minus 20 is 41.
Oh, yeah.
All right. So now when this comes down, you're going to have a +2 for the x. All right, what is the determinant here? 3 times 17 minus 10, which is 41. And 41 divided by that is -1. And so my point of intersection is 2, -1. Yes?
On the quizzes, the second system, it does not have a 5 determinant. It just has x minus 7y.
Okay. This is a different problem. I'm not sure why. All right, let me look at that again. So I just took the answer key from where it was. So, all right, let's. Oh, that's the bottom of the page. Here it is. All right, now. Okay, so let's look at this problem number 4 now. All right. Do that problem. Turn your paper over on the back side. Do that problem.
On the paper just gave us.
Yes. Yep. That was good? Did you get that?
No, I didn't.
You get it? Lee, what's going on? Lee, what's going on?
I wrote down what you had, but I feel like I'm missing something. I think
Okay.
I did the wrong one.
The denominator is going to be negative 12 minus 4. That's negative 16.
Okay, because I had the -4. That's like, how did we get to 16? Then obviously it's a 3 and -12. It changes because I didn't realize I was typing 3.4. I was doing 2 by 3, which doesn't make sense. I was trying to catch
No,
the
see,
X's.
no, you're supposed to use Kramer's rule,
Yeah.
so you have to use the determinants for Kramer's rule. That's different than using the calculator.
Right.
Yeah, you're right. If you do it in the calculator, all right, now you should have got this answer with the calculator, right?
Yeah.
Okay, but that's not what it asked for. It said
Right.
solve using Kramer's rule, and that's why you didn't get credit for that problem. What the answer was that you didn't demonstrate Kramer's rule. And you weren't the only one. There was a number of people that didn't read the directions. They just solved the problem and attacked the problem. I'm teaching a class on Friday with a student who we're going into matrices where these types of skills that we're learning here, she's going to be using them to be able to solve those problems. And so the question is going to be whether or not they're asking to demonstrate something or whether or not they just want the answer. All right, but this problem asks you to demonstrate Kramer's rule. All right, and so you've got to show me this is the very minimum that you could do. All right, because I did all of the determinants in my head. You know, but normally, what would you do for this is that you would want 3, 2, and 2, -4. You want the determinant for that over 5, 14, 2, -4, the determinant for that. So that's 20 minus 28, which is -48. That's where this came from. And then here I have -12 minus 4, that's -16. All right, and so that's where the +3 comes from. But you're supposed to be able to demonstrate the values based on what you know about Kramer's rule. Okay? Good. All right. Okay. So let me go back here. Let's go to the next section. Okay, so now we're in week 10. And we're going to look at 5-2 in your book. All right, so let's open, I think it's 186. Hope I got that right. All right, now if you remember last week, we talked about quadratic functions. And you were looking at values for vertex and intercepts. All right, so that's 5. So I'm going to get to that in a second. Let me come off of that for a second. Where's the mouse? There it is. Okay. sorry. If you have a quadratic, you have ax squared plus bx plus c, and we set it equal to 0, and from that we get quadratic formula, right, which is negative b plus or minus square root of b squared minus 4ac all over 2a. Right? We're going to use that again because that's how we find the values of x. But to find the vertex, there are two methods. One is using negative b over 2a, which is part of the quadratic formula. The negative b over 2a gives me the x of the vertex and also gives me the line of symmetry. All right? So I can use the line of symmetry will be x equals negative b over 2a. And the vertex is going to be negative b over 2a, comma, f of negative b over 2a. You just put the value in the function and find out what the y is when x is whatever that number is. Okay? Now, the y-intercept is f of 0. Is the y-intercept. Because when x is 0, whatever's left becomes the y value of 0, comma, y, which is the y-intercept. Right now, if you have those points, you could probably, with those points, graph. And then the next part is called the x-intercepts. And that is the solutions. Okay? Now, I'm going to show you a trick. We have already used second calc intercept, where two lines cross, right? Okay? So let's try, just for the sake of demonstration, let's go into y equals, and let's use 3x squared minus 5x minus 7 as my y equals. So put that in your calculator. Okay? Now, if we had to find the vertex and we use negative b over 2a, it would be negative 5 over 6. Right? Now, that's ugly, but that's what it would be. And then if we save that into x by using store x, and then put this equation in, we could find that. But when you use second calc, we can find the zeros, which is number 2, right? But there's a faster way. Okay? Go back to y equals. Go to the second equation and say y equals 0. Now look at the graphs. If you've got a colored graph, what it's going to show you is it's going to show you a parabola, and then it's going to show you a red line going along the x-axis, because that's where y equals 0. Now, we want the intersection of those two lines. So that's faster to do. So now if we go second calc, intersection, which is 5, and then it's already said, can the first one be the curve 1, so you press enter, yes, and it automatically jumps to the second one. Can the second one be curve 2? Yes, and then you press one more time and it gives you the intersection. And the intersection for this one, because it's ugly, is at an x of negative 0.906 and a y of 0. That is the first intersection. Okay, now, how do I get the other 0? I've got to start again, second calc, 5, but now I need to move left to right and get around the curve so that I'm closer to that second crossing of the x-axis. And then you press enter, 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 and you get the second one is at 2.573, 0. Now, if we did the quadratic formula, those are the same two answers we would get. We would get x is this and x is this. So if you're only trying to find the answer and you're not trying to demonstrate something else, you can put the equation into y equals and then put an equation for y equals 0 and look for the intersection, and it's the fastest way for the calculator to get you the two values of x. So x equals negative 0.906 and x equals positive 2.573, because those are the values where the parabola crosses the x-axis, which is the point y equals 0. Okay, so that is one of the skills that you're allowed to do. Now, with this information, this, and those other information, now you have 5 points. You've got two solutions, you have an intercept, you have a vertex, and you have a line of symmetry. And last week we talked about it. If the line of symmetry goes through here, and if I have this point, what do I know about this point? It's the same distance, so whatever it is from here to here. So let's say that this has an x value of 7, and the y-intercept here is x equals 4. Then that means that this point right here will have an x value of 1 and the same height on the y. Because those things are symmetrical. The 7 and the 1 are each 4 units, or each 3 units away from the number 4. All right, so that's how those things work. Okay, so now what we're going to do is that we're going to look at, go back here. Okay. Why was that there? Okay, discriminant. Okay, we talked about the discriminant. All right, what does the discriminant do? Okay, this may be for your notes in case you don't remember this from last year. The discriminant, which is b squared minus 4ac, if it equals 0, then that means you have negative b plus 0, negative b minus 0 over 2a. Well, that's the same point. So there's a dual root. If the discriminant is 0, then there is one dual root, because you hit the point coming up and you hit the point going down. All right, now, if the discriminant is positive, it means that you crossed the x-axis on the way to the vertex, and then you come back down, and so you'll end up with two real roots, two real zeros, if the discriminant is positive. If the discriminant is negative, the square root of a negative number is imaginary, so you'll end up with two imaginary roots. Now, that is a test question. What does the discriminant tell you? All right, you calculate the discriminant, b squared minus 4ac, all right, from the a, the b, and the c of the trinomial, and then if it's positive, you say there's two real. If it's 0, you say there's one dual root. If it's negative, you say there's two imaginary roots. That's what the discriminant tells me. Okay? Now that's not new, is it? It's probably, been solidified a little bit more, but we worked on that last year. All right, and so that's going to tell you a lot. Now, one of the things that's interesting is that if you graph an equation that has an imaginary root, you can still find the vertex, because the vertex will be can be found using completing the square. But if it's a positive root and it's going up, if it's an imaginary, it means that the whole vertex is above the x-axis, and so it never crosses the x-axis. So you have a real parabola that you could graph, but it doesn't cross the x-axis, and how we'll know that is the discriminant will be negative. If the discriminant is positive, it means that the x-axis is here, and the graph has a vertex that's below the x-axis, so that it hits it in two different places. Okay? And if the discriminant is 0, it means that the vertex hits right at one point, and it hits it in both directions. Okay, so that's, and again, that's in their skill. So, vertex, negative b over 2a. And if you find the x value of the vertex, then you'll put that value into the function, and you'll be able to get the y value of where the vertex is. And then you can get the y-intercept, it's the constant. Right? Then the x-intercepts are x equals, and then you can use zeros in second calc. Or you can use what I just showed you, and that is put the 0 in, and then you can use interception. All right. Now, completing the square. How do you complete the square? You use half the middle term. All right. Now, this is the more complicated completing the square. Let me get this. Pull this. Pull it down. Okay. So we're going to talk about completing the square here. Let me move this just a tad. All right, now, most of the time, completing the square, this is 1x squared. So this is the harder version. In order to be able to do completing the square, where you take half the middle term, you have to have 1x squared. So in this case, I have to factor out the 2. Now, I was nice. I gave a value that had 2 on both sides, so it was very easy to factor out. So when I factor the 2 out, I'm left with x squared plus 4x here, and the plus 17 I didn't change. Right now, what is half this middle term? 2. So therefore, x plus 2 squared is the binomial, but I have an a of 2 instead of an a of 1. Now, this is 2 terms. One is 2x squared, the other is plus 4. The third term I've introduced is 2 times 2, 4, but now it's 4 times 2. So I have a positive 8 that I've added that wasn't in the problem originally, so therefore I have to subtract 8. So I have 4 times 2. Before, what we were doing when this was 1, we were just saying that this is 4 because it was 4 times 1. All right, we'll do another one so you see that. So now, what is the extra term? Now, I have 17 minus 8, which is plus 9, and my vertex is now at negative 2, comma 9. Right, that's with completing the square. If I didn't want to complete the square, I would have negative b over 2a. Look at the number. What is negative b over 2a?
Negative 2. Oh no, sorry.
Yeah, it's negative 2. Right? Same number. Which was faster to get? I don't know. Right? Maybe negative b over 2a, but we're not done. So now let's do this. Let's put -2 stored to x in your calculator. -2 stored to x. Then put 2x squared plus 8x plus 17 in your calculator. Find out where the y value is when x is -2. So we're going to put -2 stored to x, press enter, then you're going to put in 2x squared plus 8x plus 17.
It's 9.
No, whoa, it's the same number. Okay, so we can use -b and then comma f of -8/4, right, by substitution, or we can complete the square and the value will be here, right? It'll be the opposite of the number that's in the parentheses. It'll be the same number that's on the outside for the x and y. Okay, all right, so let's do another one. All right, I'll make it easy, all right? Okay, so let's take 3x squared minus 12x plus 7. Okay, now, the first step is to get 1x squared. In order to do that, I have to factor. Okay, so I'm going to pull the 3 out, and what am I going to have in here for these two terms? I'm going to have 1x squared, and I'm going to have a minus 4x. Now I can take half the middle term. It'll be x what? Minus 2. I didn't mean to make both of those 4, it just was what it was. All right, but what's out here now? 3. Okay, so now the extra term in here is 4, but now it's 4 times 3. So I have a positive 12 I'm adding, so I have to add a negative 12, and that'll make this -5. And so my vertex is at 2, -5. All right, now let's go back to here. When x is 0, y is what? In the original problem, when x is 0, y is 7. So the y-intercept is 0, 7. Now, because we made this problem up, the solutions, the x-intercepts, or the solutions are going to probably be pretty ugly. All right, so let's use the calculator to find that. Let's go to y equals. Oh, wait a minute. No, let's do discriminant first. I'm sorry. Hold that thought. Let's do the discriminant. The discriminant is -b, which is 12, over 2a, which is 6. And that's where I'm going to get the positive 2 again. So the line of symmetry is equal to x equals 2. All right, now look at this. This is 0. How far is it from here to the line of symmetry? From here to the line of symmetry. It's 2, right? Isn't it 2? Right? So if this is the line of symmetry, then this is 2 on this side. So, let me do it this way. 2, -5 is down here. Line of symmetry is coming up like this. All right, this right here is 0, 7. It is 2 away, so 2 away over here, which is 4, 7, is also a point on the graph. That's using the line of symmetry, because this is 0, 7. It takes 2 to get to the line of symmetry. Another 2 will put me 4, 7. That's also a point on the graph. So now when I look at that, I can almost see where these are going to come down. All right, so now let's put this in y equals, leave the y equals 0 in number 2. Let's put this in y equals on the first part. That's almost the same, isn't it? And you know you can overwrite some of those numbers. You don't have to clear it all, you can overwrite it. So 3x squared minus 12x plus 7. So then how do I find the zeros using intercept? Second, calc, and I want intersection. Then you get the second one, you do the second count, 5. You have to move your cursor. The x-intercepts are at 0.709 and 3.291 is what I got. Is that what you got? Okay. And so now you have 2 points here. We have a third point. We have a fourth point, and if I add using the line of symmetry, I have 1, 2, 3, 4, 5 points, which should very easily graph that particular equation. Okay. Now, I'm going to add one other skill to this, and that has to do with the vertex. All right. If I calculate the vertex to be at 2, -5, and that's this point right here. If I go over 1, I go up 1 times 3. So if I go over 1 on this, I'm at 3, and if I go up 3, I'm at -2. That's the point on the graph. If I go back 1, I go to 1. If I go up 3, I'm at -2, and that's the point on the graph. From this point, if I go over 2, I go up 4 times 3, I go up 12. So over 2 from this is 4, up 12 is 7. That's the point on the graph. If I come back 2, I'm at 0. If I go up 12, I'm at 7, and boy, doesn't that look familiar. What is 0, 7? That was the y-intercept that we found in a different way. And it turns out in this case that the y-intercept was exactly at 2 units over from the vertex. That doesn't always happen, but it did this time. All right, but what I'm trying to show you is that if you have this, once you find the vertex, then you're over 1 up 1 times whatever this number is. And we started out with that was 1. In this case, you can actually get those points and then graph it, and you will be very accurate. Does that make sense? Or a question about that? No? Okay. All right. All right, now, let's see if I get this back and running. Okay, so now let's look at page 180. 180. And chapters? Is this chapter 2? This is part of your homework last week. You were supposed to do, in 5.2, you're supposed to do 3 through 30. Okay, so in 20 through 30, did you have a problem coming up with the points for the vertex, the y-intercept, the line of symmetry?
Yes.
Yes.
You did, okay, why? All right, number 20, how do you find the vertex? The vertex, all right, if we want to complete the square, we could, but the vertex would be negative b over 2a. So if the b is 8, negative b is negative 8 over 2, which is negative 4. So the x value of the vertex is negative 4. So let's put a parentheses and write negative 4 down for the x value to start with. How can I find the y value of the vertex? I want the function when x is negative 4. So store, or negative 4, store to x. Negative 4, store to x. And then in the main screen, put x squared plus 8x plus 21. Negative 1? All right. You put x squared plus 8x plus 21. All right. And if x is negative 4, what's the answer when you put x squared plus 8x plus 21 and then press enter in the calculator? 5? Positive or negative?
Positive.
Positive. So therefore the vertex is right there. Now, what is f of 0? It is 0, 21. That is the y-intercept. All right, the line of symmetry. The line of symmetry says x equals what value? Look at the vertex. What's the x of the vertex? Negative 4, so x equals negative 4. Okay. Now, using the line of symmetry, I can also say that if I'm at negative 4 and I'm going over here to 0 to get to the 0, 21, then at negative 8, 21, I also have a point on the graph. So the line of symmetry is at negative 4. I go in a positive direction to get to 0, and then I'll go negative 4, which will be negative 821 is also a point on the graph. And with those points, 1, 2, 3, those 3 points, you should be able to put that graph in. And because number 20, the x squared is 1, we don't have the same issues that we had in the other. All right, now let's look at 22. All right. I could use the completing the square, but the first thing I have to do is factor out the 5. Agreed? So if I factor out the 5, I have 5 times x squared minus 6x, and that'll be nice, and then plus 31. All right, now, half of this term?
Minus 3x.
So, it'll become x minus 3 squared with a 5 in front. So, 3 squared is 9. but 9 times 5
45.
is 45. So I've added a positive 45, so I have to add a negative 45 so that I don't change the problem. And that gives me negative 14. Now I can find the vertex. The vertex is at 3, negative 14. My y-intercept, I've got to get from the book, will be 0, 31. Okay, now, where's the line of symmetry? X equals what?
3.
X equals 3. So if x equals 3, I go in the negative direction to get to the 0, so that means I'll come in the positive direction, and I'll have 631 as another point on the graph. And now I have a vertex, a line of symmetry, and 2 other points, and I should be able to draw that graph. If I start at the vertex, I go over 1 up 1 times 5, over 2 up 4 times 5, which is up 20. So if I want to just put a dot on the vertex, I'll be over 1 up 5 and over 2 up 20 because it's 4 times 5 and it's 1 times 5 in both directions. Does that make sense? Does that make sense on the graphing? Okay, I hope it does. So you have 2 ways. Which was easier? I don't know. But that's 2 different methods of finding points, and that does not include solving the equations to find the x-intercepts, which is the next chapter. Okay, so that takes us. Where's my erasing paper? Here it is. Okay. All right, now, if you had problems with those, this is the reason why I have given 2 weeks for this, is go back now and see if you can get those answers. Okay? Now, let's look on 5.3. All right, 5.3 is the quadratic formula. All right, the quadratic formula will help you get the x values where y equals 0. I'm on page 182. All right, now, one of the reasons that you look for the discriminant first is if there is no real solution and you try to use the calculator with the quadratic formula, you end up with an error on the calculator because the calculator cannot take the square root of a negative number. So that's why you're supposed to check the discriminant first. All right, that's the bottom of 183. All right, so turn to page 184, and I've already talked about this. This is the nature of solutions given the discriminant. If the discriminant is negative, what does that tell you? No, it tells you something else. It tells you you have 2 imaginary answers. Okay? It's not just anymore that there's no solution, but the discriminant says 2 imaginary. All right, if the discriminant is positive, it tells you you have 2 real answers. If the discriminant is 0, then you have 1 dual answer because you have negative b plus 0 divided by 2a, and negative b minus 0 divided by 2a, which is the same number. That's why it ends up being called a dual root. Okay? All right, now, on page 185, we've already used this. The h, which is the x value of the vertex, is negative b over 2a. Okay? That should not be news. You need to know how to use that. All right, now, so now when we turn to on page 187.
So too many numbers.
Too many numbers. Okay, just more problems, okay? All right, now, so in problems 1 through 20, it says solve the equation. All right, so that's going to be just the two x values of the solution. All right, now, does it say solve the equation using blah or blah?
No.
Okay, so how could you solve this using second calc? You put the equation in y equals, and then use second calc zeros. And you'll take the cursor and you'll say between these two values, between these two lines, tell me where the y is equal to 0. And then you'll do second calc zeros again, and you'll move the cursor left or right and say between these two lines, tell me where the y is 0. Okay? Now, if you had to use the quadratic formula, it would just take longer, but you would have to do negative b plus square root of b squared minus 4ac. So let's look at problem 2. Let's look at problem 2. And let's consider what we have to put in the calculator. If we're going to use quadratic formula. All right, so problem 2 says x squared minus 5x plus 6. Oh, isn't that cool? By the way, if you look at this, isn't x minus 2, x minus 3 the solution to that?
Yes.
Well, wait, well, look at it. All right, first term is x, last term is plus 6, and 2 plus 3 is 5, so that'll be the, all right, and we'll see that in a second. Okay, so we have this, and what we're going to do is we're going to put this into the y equals. So go ahead and do that, and put the equation in the y equals. Then you're going to go to second calc after you get the equation in. And press number 2 because that's the 0. And that's going to send you to this particular parabola, and it's going to say left boundary. So let's say it's crossing here. If I need to be here, I need to move my cursor to the left so that it's sitting up here. And press enter. Then move your cursor to the right until it gets below it and press enter. And then it says, do you want to guess? Yes. So you press enter again, and then down here it'll give you an x value and a y value for the point where that cursor is right there on the x-axis. That's the solution. So the value of x, because y is 0, the value of x is the value of x that makes y 0. Right now, how do you get to this one? You go back to second calc, and now when you come in, now you've got to move the cursor to the right because it's sitting here, and you move it so that it's under here. Press enter, then move it again so it's up here, and then between these values, you want where y is 0. When you press guess again, it gives you the second point. And again, that's the values of x that make y equal 0. That's the solution to the equation. So, solution equals zeros equals the y or the x intercepts. And see, in Algebra 1, we were talking about solutions. The zeros are the solution because it's where y is 0. Okay? All right, so now when you look at the first section, 2 through 20, you're just solving. Now, if you wanted to use the quadratic formula, let's go back to this problem. If I want to use the quadratic formula on this, then what I have to say is negative b, which is 5, plus or minus the square root of 25 minus 4 times 6. That looks like 1, doesn't it? 25 minus 24, all over 2, which is 2a. So I have to put in the calculator, depending on the values of the calculator, I have to put parentheses 25 plus square root of 25 minus 4 times 6, all right, close parentheses for the numerator, divided by 2. The newer calculators, they set this up as a fraction, so you have to use the arrow key to come out instead of that parenthesis. And then, now when you do that, then you do second calc, come up here and change that to a minus, and it gives you both of them. Now, did you do this particular problem? What answers did you get? Do you remember?
We didn't do 5 for this.
No, I'm sorry. Didn't you just put it in the calculator?
Yes.
Okay, what'd you get for answers? 3 and 2, right? You know why? Because if we factor this, this is x minus 3 times x minus 2 equals 0. In order for this to be a 0, x has to be 2. In order for this to be 0, x has to be 3. And so the values of x are x equals 2 and x equals 3. And so the calculator comes through here, and this is on 2 and this is on 3, and my vertex has a line of symmetry of 2.5. Why? Negative b over 2 will be a positive 2.5. That's the line right there. Now, where's the vertex? I'm sorry, where's the y-intercept? It's at 6. So 0, 6, this is at 2.5. 0, 6 is 2.5 in that way. So this is 0, 6. And on this side, if I go 2.5 in the other direction, I'll be at 5, 6. That's also a point on the graph. And x equals 2.5 is that right there. All right, now those are the major points that you're going to learn to find and graph. Okay. Algebra 2 is the hardest high school math class because there's so many things you have to learn, and all of them seem to be different. Okay, and so you don't be overwhelmed. Just realize that this is just more work. Okay, now all of the problems on this page are basically asking about the same thing. Okay, so in 5.3, the assignment is 24 to 50. All right, that's on page 187. 24 to 50 turns, no, it can't be. Wait a second. It doesn't go that far. That's weird.
You can do 4 to 46.
Yeah. You can stop at 44 on that one. Okay, and then in 5.4, which there you've got to be careful about negative answers. I'm sorry?
This one doesn't go to 54 yet.
It goes to 25.
That is weird.
You can do 10 problems.
Let me check something. 2020. That's what it says.
It's not.
Is that up to me?
Huh?
No, this is, no, but this is Algebra 1. At the top.
Yeah, that does say Algebra 1.
I mean, I can go back and do the Algebra 1 lesson, that's okay.
I'll do that, I still have the book.
All right, you guys are in the same chapter.
Ooh,
Coincidence.
coinky-dink.
That's Algebra.
This is Algebra 1 also. But I'm in Algebra 2.
Is it the one right next to it?
Algebra 2 lesson plans to the one to the left. That could be it.
That's weird.
Maybe.
Okay, we're doing the same thing, okay. Yeah, okay, yeah, because this is the one I gave you last week. Okay, yeah, so we're doing 2 through 46 and 2 through 24, okay. All
Oh,
right. Okay, now, in, all right, turn to page 194 real quickly. That's weird. Why would they put the lesson plans for Algebra 1 in the middle of Algebra 2? Because technically, I'm looking for that light blue thing, because that was that's weird. All right, okay. So, on page 194, all right, and on 194, if you do the quadratic formula, let's see, x squared negative 10 plus 26, right? Okay, so we have x squared minus 10x plus 26. All right, now, first of all, if we do b squared minus 4ac, we have 100 minus 4 times 26. So it's a negative, it's imaginary number, because it's the square root of a negative number. Okay, so what I'm going to have to do is I'm going to say opposite of b, 10 plus or minus the square root of 100 minus 4 times 26 all over 2a. Now, put this in the calculator without the square root. Put 100 minus 4 times 26 in the calculator. Negative 4, right? Okay, that means that this is the square root of 4i. So I pull the negative out by making it into an I. The square root of negative 1 is I. That's imaginary. Now I have this. 10 plus or minus this over 2. Is the square root of 4 2? So therefore, I can cancel this and I can simplify this to 5. And I have 5 plus I. And I have 5 minus I as the two solutions to that problem. Last year, we would have had to have said, null set, there are no solutions. This year, we're going to take the negative out, the square root of negative 1, change it to I, and keep working. Now, what will happen is these will always be in pairs, because it's going to be negative b plus or minus something I. So they're always going to be in pairs. One of them can't stand without the other. Okay? Does that help? All right, so let's look at, where were we? Is that 4? All right, let's look at problem number 5, same way. All right, problem number 5 says 9x squared plus 12x plus 68. Now, there are no negatives in here, so this whole thing has to be above the graph. Okay? Now, so when we look at it, what are we going to do for the quadratic formula? We're going to take negative 12 plus or minus the square root of 144 minus 4 times 9 times 68. All over 18, 2a. All right, so now, first thing you have to do is what? You've got to simplify what's under the square root, the discriminant. $144.
It's negative 2,000.
No, don't use the square root. Use the discriminant without the square root. You're right, because it's negative. What'd you get me?
Negative 2,304.
Okay. Can you take the square root of that?
No. I mean, you
just do it.
well,
And that's like 48. Positive square root of 2,304 is 48.
Okay. So, all right, I don't have that problem with me here. Let's see. Put it on this page. It says it simplifies to 8 times 6. That is 48, right?
8 times 6, yes.
Okay, so this is going to be negative 12 plus or minus 48i all over 18. Now, you can divide each of these by 6. Maybe no, can't do it by 12. So you can divide it by 6, and so I'll have negative 2 plus or minus. I'm going to do that by 6. I have 8i over 3, and there's 1 for plus. And there's 1 for minus. You could have left it with the plus or minus, but I'm trying to show that there's 2 answers. There's 1 with a plus and 1 with a minus. Okay, now, so when you do these with the quadratic formula, you're going to have to, I think they're all going to be a relatively good amount until you get to problem 12. Amen. And we're not plotting the complex numbers, but if you did plot them, the x value is the real and the y value is the imaginary. But in real life, the x value and the y value come here, and the imaginary comes out into space. So if you would go along the x-axis, and then you'd come out with, like, and this is 8i, right? So if this is the origin, right here, we would go negative 2 on the x, and we come out 8. Oh, I'm sorry, negative 2 divided by 3. So I'm going to go over this way, negative 2/3, and then I'm going to come out 2 2/3, and the value would be up here. And technically, it would be a line that's coming through here, coming to this point out there. But we don't do that. So that's the reason why we don't stress that here. Okay, what time is it? 4, I'm good. All right. Okay, so work will be 5-3, 5-4, and go back and pick up 5-2. All right, that should make more sense now. So I'm going to put down 5-2, 5-3, and 5-4. And then I'll send you the chapter 4 test.
You already took the chapter 4 test.
What? Oh, that's right. We were ahead on that. Good. All right.
Is it to be turned in today?
I think so. Because I got Lisa's email the other day. Okay. Wow.